Hello class, this is Mr. Eggleston. I'm here with my Algebra 1 student Layla Wilson, who's quietly taking the quiz, very quietly. And this is the review for your quiz 6.5 through 6.9. The quiz, the video of me going through the review, I promised you a week and a half ago that I forgot. And now your quiz is coming up like tomorrow and Friday. So this is the video for it. Here we go. To solve an equation by factoring, A, you have to know how to factor. B, you have to make sure the equation is equal to 0. So you notice on question number 1, it's not equal to 0. So what we're going to do is subtract 8n from both sides. When we do that, we have n squared minus 8n plus 15 equals 0. Now we can factor. We're looking for two numbers that multiply to 15 add up to negative 8. And I hope you guys would realize it's negative 5 and negative 3. So we can write that polynomial, that quadratic in factor form as n minus 5, parentheses, n minus 3 equal to 0. Gives you two solutions, n equals 5, n equals 3. There you go. On numero dos, it's already equal to 0, he knows that, so we don't have to rearrange it. So we're going to go through the factoring process. First thing, when there's a number other than 1 in front of the squared term, you always try to GCF. Can 3 go into 19 and 6? Well, it goes into 6, but it does not go into negative 19. So we can't GCF. Then the next thing is we look for product sums. What two numbers multiply to 3 times 6 is 18 and add up to negative 19? It's negative 18 and negative 1. Okay? So then we draw our box. We're going to undo, the FOIL process. Remember, you could always draw a box to do FOIL. Well, we're going backwards now. So we put the first term here in the first upper left box and 6 in the bottom right. And then we know 1 is going to be negative 1k, and the other one is going to be negative 18k. All right? So looking at this, you can ask yourself, like what's common between those two, and I hope you would see that it's 3k, it's just k, not 3k, k, kk. So there you go. What's common between these two? Well, that's going to be a 6. I'm always a little concerned about the negative sign. So you know what? What do we have to multiply k by to give us 3k squared? I'm just going to go that way, and that's going to be 3k. So now that we got that, right, 3k times k gives me 3k squared. You can then ask 3k times what gives you negative 18k, and that's going to be negative 6. Okay, and then negative 6 times what will give you positive 6, and that's going to be negative 1. You could also have said, you could have asked yourself, k times what will give you negative k? So now we got this factored. It's 3k minus 1, parentheses, k minus 6, equals 0. Now set each factor equal to 0. If 3k minus 1 equals 0, 3k equals 1, k equals a third. On the second one, if k minus 6 equals 0, then k equals 6. Those are my two solutions. All right. Then question number 3 is solve each equation by completing the square. So now to complete the square, we're going to have to subtract. We want to get the x terms by themselves. So this is x squared plus 18x. I'm going to subtract 73 from both sides. So 8 minus 73 is negative 65. Now take half of the number in front of x. So that's half of 18. Square it and add. Now, yes, I know what half of 18 is. That's 9. So this is really just going to be negative 65 plus 9 squared, which is 81. So now we have negative 65 plus 81. What is negative 65 plus 81? I don't know because I just screwed it up. Negative 65 plus 81 is 16. So now we have x plus 9 squared equals 16. Take the square root of both sides. Now we have x plus 9 equals plus or minus the square root of 16, which is plus or minus 4. Subtract 9. It's negative 9 plus or minus 4, which gives us two solutions, negative 9 plus 4, which is negative 5, and also negative 9 minus 4, which is negative 13. So the answer is negative 5 and negative 13 are the two answers to equation number 3, and we solved it by completing the square. All right, for question 4, they want you to take that ugly expression and rewrite it so that you can, in the form, the general form, not the general, but the standard form in the equation of a circle, which is going to be like x minus 3 squared plus y minus 3 squared equals like 25 or something. Because then you know that the vertex, or not the vertex, the center of the circle is at 3, 3, and the radius is the square root of 25. So we want to take this mess and complete the square twice to make it look like that. So to do that, we have to kind of put the x's and the y's together. So what I'm going to do is put the x squared and the negative 12y together, or negative 12x, excuse me. I'll leave a little space, and then I'll have negative or plus y squared minus 10y. Leave a little space. I'm going to move the negative 39 over by adding 39. So I have that. Then, completing the square on the x term, we're going to that's supposed to be we take half of the number in front of negative 12 of x, which is negative 12. Half of that, that's negative 6. And we're going to square and add that. And we're going to have to add that to both sides of the equation. So that's going to be plus negative 6 squared. And then over here, it'll be plus negative 6 squared. And okay, what's nice is this right here turns into x minus 6 squared. Now we're going to have to do the same thing for this piece, which I'm going to change the color. Okay, so what we're going to do is take half of the number in front of y, which is half of negative 10, it's negative 5, square it and add to both sides. Okay, now what's kind of cool is, and that's kind of a funky, that's supposed to be y squared, all in that purple, pink, whatever color that is. This thing on the left, this purple, just collapses into y minus 5 squared. And then that whole kit and caboodle is equal to 39 plus 36, because that's what negative 6 squared is, plus 25. That's what negative 5 is. So 39 plus 36 plus 25, 39 plus 36 plus 25 is equal to 100. Okay? And that's your equation of a circle, where you can now easily read off where the center of the circle is. So the center is going to be at the ordered pair. Remember, your variables are liars, so it'll be at 6, 5, and the radius squared equals 100. So the radius, r, equals 100 square root of 100, which is 10. And there you go. You found the radius and the center of the circle. And it was kind of ugly. That was a rough question. Now, you will be given the quadratic formula. So you don't have to remember it. But the quadratic formula is x equals the opposite of b plus or minus the square root of, that's got to be longer, b squared minus 4ac all over 2a. Bum 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 bum. So now filling in everything we know, but okay, that's the quadratic formula. The thing underneath the square root is the discriminant. Okay, so d is equal to b squared minus 4ac. So now plugging in what a, b, and c are, a equals 8, b equals 9, c equals negative 1. So that's going to be 9 squared minus 4 times a is 8, times c is negative 1. That equals 81. Negative 4 times 8 is negative 32, times the negative 1 is a positive 32. 81 plus 32 is 81 plus 32 is 113. So the discriminant d is equal to 113, which says since d equals is equal to a positive number, we have 2 real solutions. Okay? And that's how you answer that. It's not too hard. All right, that was question 5. Question 6 y 7 y 8 y 9, 6 through 9, we're dealing with those pesky complex numbers. Now, I don't like the way this is written. So I'm going to rewrite this as negative 2i minus 6. I'll put the parentheses like that. Plus negative 8 minus I. All right. I don't like the fact that the I is in front on this first term. Usually it's real plus the complex, the imaginary part. So I'm just going to switch it and rewrite this as negative 6 minus 2i. And now it'll look like this. Okay. We add the real, we combine the real and the real. So negative 6 plus a negative 8 equals a negative 14. And then what is negative 2i plus a negative 1i? Well, that's going to be negative 3i. And that's the answer. You have to make sure when you add and or subtract, you're going to add real to real, imaginary to imaginary. All right, this next one, very similar, 5 plus a negative 2. We're not multiplying because there's a plus between them. So it's 5 plus negative 2 plus 8i plus a negative 5i. Okay, 5 plus negative 2 is 3. 8i plus a negative 5i is 3i. So it's 3 plus 3i. Again, you don't have to write it like this. You could just go 5 plus a negative 2 is 3. 8 plus a negative 5 is 3i. Okay? Now, when we're multiplying, we have to distribute twice. So negative 2 times negative 5 is negative 10. Negative 2 times 8 is negative 16i. 7 times negative 5 is negative 35i. And 7 times 8 is 56. I times I is I squared. All right? Now, what's interesting about the I squared, you have to remember I squared is equal to negative 1 by definition. So it's really plus 56 times negative 1. Well, 56 times negative 1 is negative 56. So we have negative 10. Now, negative 16i, I'm looking at these two, I'm combining the i's. Negative 16i and negative 35i is negative 51i. I hope I got that right. Okay, and then I squared is negative 1, so that's 56 times negative 1, that's minus 56. So negative 10 minus 56 works out to be negative 66 minus 51i. And there's the product of those two complex numbers. Now, we're not doing a lot with the complex numbers, so that's about it. All right, again, multiply. Distribute twice, or FOIL. 3 times 3 is 9. 3 times negative 5 is negative 15i. Let me scooch it down so I have space to draw my rainbows for the distributed process. 5i times 3 is a positive 15i. And 5i times a negative 5i is negative 25i squared. So we have 9, the negative 15i and the positive 15i sum to 0, and I squared happens to be negative 1. So negative 25 times negative 1 is a positive 25. So it's 9 plus 25, which is 34, which is a simple integer number. Okay. Notice there's no complex part to that product. That is because the imaginary part cancels out. We call these two numbers conjugates. Complex conjugates. Notice they are almost exactly the same except for the sign in front of the I are switched. So one's 3 plus 5i, the other one's going to be 3 minus 5i. Okay. And when you multiply conjugates, you get a real solution. You just get 34 in this case. No complex part. All right. From the graph, determine the type and number of solutions and sign of the discriminant of D. Well, the discriminant is the thing that's underneath the radical, right, in the quadratic formula. And it tells us if D is positive, then we have 2 real solutions. If D equals negative, we have 0 real solutions. And if D equals a negative, you have no real solutions. So in this case, all right, so in this case we have one real solution. I did negative twice. Look at that. Oh, man, I am tired. If it equals the number 0 is what I was meant to say. Then we have one real solution. So you see, the graph just touches the x-axis. So that means there is one real solution because it touches the x-axis once. And the sign of the discriminant D is going to be equal to 0 because it's just one solution. And remember, the quadratic formula can be written as x equals the opposite of b plus or minus the square root of d, where d is the discriminant, all over 2a, which is the same thing as saying the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So d is just the b squared minus 4ac. And if D, if D, I use capital D on my, so that's going to be capital D. This will be capital D, and that's going to be capital D. Okay. All right. Okay. All right, so that's how you do it. So if you had a graph that touched the x-axis twice like that, that's two real solutions, and the discriminant would be positive. And if you had a graph that never touched the x, like that or like this, then it would be d is equal to a negative, which is this example. That's supposed to be negative. And that means no, I shouldn't say 0 real solutions. I should say no real solutions. Or 2 complex solutions. All right? So, and the last question is just, if they give you a complex number 4 minus 7i and they ask you what's the conjugate, all you got to do is change the sign in front of the imaginary part. So that's 4 plus 7i. If they had given it to you as 7i, negative 7i plus 4, the conjugate would have been 7i plus 4. Okay? You change the sign in front of the imaginary part. And that's it. That's your quiz. Hope you understood it. Have a great day. I'll see you next class period.